square and a cube.
We will study square and cube.
Queen Ratna Manjuri had a will written that described her fortune of Ratnas, precious stones, and also included a puzzle.
Queen Ratna Manjuri had a will written that described her fortune of Ratnas, precious stones.
Actually, Queen got a will. Will means a document. It is document means a family member writing his assets to their children. This will go to this boy.
After
This
death,
land, yes, these buildings will go to this daughter. Like that, it is will.
And
Like that, she got the will, precious stones.
and also included a puzzle.
her son Koishnam and their 99 relatives were invited to the reading of her will.
99 relatives asked to read the will. Everybody read the will.
She wanted to leave all of her ratnas to her son.
Her son Koshnam.
She wanted
She wanted to leave all of her ratnas to her son.
to her son, she want to give. Next.
But she knew that if she did so, all their relatives would pester him forever. She hoped that she had taught him everything he needed to know about solving puzzles.
Solving puzzle means we should solve puzzle. What happened? She know means she understand. That if she did so, all their relatives would pester forever. Next.
She hoped that she had taught him everything he needed to know about solving puzzles.
He should understand how to solve puzzle.
She left the following note in her will.
Note means writing some details in her will. Will means what? Will means the parents giving their assets to their children.
I have created a puzzle. If all 100 of you answer it at the same time, you will share the ratnas equally.
If you solve the puzzle, you can share details, ratnas.
However, if you are the first one to solve the problem, you will get to keep the entire inheritance to yourself.
Good luck. The minister took Koishnam and his 99 relatives to a secret room in the mansion containing 100 lockers.
100 lockers in a house. He called all relatives.
The minister explained each person is assigned a number from 1 to 100.
Everybody will give one number. This fellow is 1, that fellow is 2, like that.
Person 1 opens every locker.
He can open all the locker.
Person 2 toodles every second locker. Closes it if it is open. Opens if it is closed.
Person 3 toggles every third lock, third, sixth, ninth, and so on.
First fellow open all. Second person, what will do? Second locker, that is closes if it is open, opens if it is closed. Third one, 3, 6, 9 and so on.
person for toggles every fourth locker, 4th, 8th, 12th, and so on.
Fourth person will 4, 8, 12, like that he will open.
This continue until all 100 get their turn.
Everybody will do.
In the end, only some lockers remain open. The open lockers reveal the code to the fortunate in the safe.
That will give the answer.
Before the process begins, Koshnam realizes that he already know which locker will be opened at the end. How did he figure out the answer? Hint: find out how many times each locker is toggled. If a locker is toggled an odd number of times, it will be open. Otherwise, it will be closed.
Odd number means 1, 3, 5, 7, like that.
The number of times a locker is toggled is the same as the number of factors of the locker number. For example, for locker 6, person 1 opens it, person 2 closes it, person 3 opens it, and person 6 closes it.
The number 1, 2, 3, and 6 are factors of 6.
This is the 6 factor is 1, 2, 3, 6. Why? We can divide 6 divided by 1, 6. 6 divided by 2, 3. We will get answer. 6 divided by 3, 2. 6 divided by 6, 1. So we can get answer.
If the number of factors is even, the locker will be toggled by an even number of people and it will eventually be closed.
Note that each factor of a number has a partner factor, so that the product of the pair of factors yields the given number. Here 1 and 6 form a pair of partners. Factors of 6 and 2 and 3 form another pair.
1 and 6, one pair. 2 and 3, the other pair.
Does every number have an even number of factors?
1.
1 into 1.
The only one factor is 1.
4. 1 into 4, 2 into 2. Factors are 1, 2 and 4.
9. 1 into 9, 3 into 3. Factors are 1, 3, and 9.
We see in some case like 2 into 2 that the number in the pair are the same.
2 into 2.
Can you use this insight to find more numbers with an odd number of factors? For instance, 36 has a factor pair 6 into 6, where both numbers are 6. Does this number have an odd number of factors? If every factor of 36 other than 6 has a different factor as its partner, then we can be sure that 36 has an odd number of factors. Check if this is true.
Hence, all the following numbers have an odd number of factors. 1 into 1, 2 into 2, 3 into 3, 4 into 4. A number that can be expressed as the product of a number with itself is called a square number.
Square number means a number that can be expressed as the product of the number with itself. 2 into 2, 3 into 3, 4 into 4, 6 into 6, same number. If it is repeats and it is square, multiply, it is called square number.
Or simply a square. The only numbers that have an odd number of factors are the squares because they each have one factor which when multiplied by itself equals the number. Therefore, every locker whose number is a square will remain open.
Just a minute.